Decades after the idea, the James Webb Space Telescope has finally made it to space. Launched on this Christmas, the telescope started its deployment after it was sent to space. Scientists are depending on the telescope to know the truth about our existence, and also if there is any other life in this universe other than ours. The telescope fans are curious to know about its deployment and what's next for this masterpiece. They are asking if the telescope is really going to find the answers to our creation. Welcome to Cosmos Lab, your one station for all the news from space. Join us in today's video to find out about the deployment of the James Webb Space Telescope, its goals, and what's next for this massive beast. The James Webb Space Telescope is the world's most powerful and largest space telescope. It is an infrared space observatory that launched on December 25, 2021, from ESA's launch site at Kourou in French Guiana, on board an Arianespace Ariane 5 rocket. The telescope will let scientists to peek back 200 million years after the Big Bang to see how our cosmos looked. Images of the first galaxies ever formed will be captured by the telescope. It will also be able to peek inside the dust clouds to see where new stars and planets are developing, as well as investigate the atmospheres of planets orbiting other stars. It will be able to observe objects in our solar system from Mars outward. The $10 billion James Webb Space Telescope will explore the cosmos to learn more about the universe's history, from the Big Bang to the birth of alien planets and beyond. It's one of NASA's great observatories, huge space instruments that include the likes of Hubble Space Telescope to peer deep into the cosmos. After being launched on Christmas Day, the James Webb Space Telescope will journey over 1 million miles or 1.5 million kilometers to its permanent home, a Lagrange point, a gravitationally stable place in space. At the second Lagrange point, the James Webb Space Telescope will orbit the Sun, L2. L2 is a location in space near Earth that is opposite the Sun. This orbit will keep the telescope in alignment with Earth as it orbits the Sun. Several other space telescopes have used it, notably the Herschel Space Telescope and the Planck Space Observatory. If Webb gets to the right zone, it can use a minimum of fuel to stay in place, thanks to a near-perfect alignment with the Sun, Earth, and Moon. The new observatory, the world's largest space telescope, successfully unfolded its final primary mirror piece on January 8th, capping one of NASA's most challenging space deployments ever. After the deployment, engineering teams cheered back at the Space Telescope Science Institute in Baltimore, Maryland, as the National Aeronautics and Space Administration announced on Twitter that the final wing was deployed. Final wing is now deployed. Short celebration, but we've still got work to do. Engineers are working to latch the wing into place, a multi-hour process. When the final latch is secure, NASA Webb will be fully unfolded in space. Webb's 5-layer sun shield, a 70-foot-long, kite-shaped structure that acts as a parasol, was deployed to keep the telescope's equipment cool so they could detect tiny infrared signals from the remote reaches of the universe. The sun shield will be permanently installed between the telescope and the Sun, Earth, and Moon, with the sun-facing side designed to resist temperatures of up to 230 degrees Fahrenheit or 110 degrees Celsius. The telescope was folded up because it was too large to fit into the nose cone of a rocket in its working condition. According to NASA, unfurling has been a sophisticated and difficult process, the most difficult of its kind ever attempted. However, it has now been successfully deployed, and according to NASA officials, we have still got work to do. So, what is this work, and what is next for this gigantic space telescope? Webb is expected to arrive at its insertion location by January 23rd. John Durning, Webb's deputy project manager at NASA's Goddard Space Flight Center, after the deployment in a press conference from Webb's control center at Space Telescope Science Institute in Baltimore, Maryland, said to the reporters that, as Webb prepares for the engine fire, team members will spend the next 15 days aligning the 18 mirror segments to essentially perform as one mirror. I should say also that Webb will start turning on the instruments in the next week or so, Durning added, and then after we get into L2, as the instruments get cold enough, they, the engineers, are going to start turning on all the various instruments. L2 is an excellent area for Webb to carry out its mission. Webb will work in the darkness required for heat-seeking infrared studies due to the considerable distance from the Sun and the use of a sun shield. Infrared wavelengths will allow the telescope to spy through the dust to examine things like nascent exoplanets or the interiors of distant galaxies, all in the pursuit of better understanding of the universe and its development. The billion-dollar Webb Space Telescope, which will be more powerful than the Hubble Space Telescope, will survey the sky for light streaming from the first stars and galaxies that were created 13.7 billion years ago. To do so, NASA had equipped Webb with the largest and most sensitive mirror ever launched, dubbed the Golden Eye by scientists. This mirror is composed of beryllium, a lightweight metal that is also strong and resistant to the cold. Each of the 18 segments is coated with an ultra-thin layer of gold that reflects infrared light extremely well. You can know more about the structure of the James Webb Space Telescope in our previous video. The Webb mission crew is now focused on guiding the telescope to its first destination while also bringing crucial components of the observatory online for astronomy research. The hexagonal coffee table-sized segments must be adjusted in the days and weeks ahead, so they can focus as one on stars, galaxies, and alien worlds that might hold atmospheric signs of life, the main goal of this telescope. This universe is vast, and the scientists are curious to know about it. Many missions have been conducted and telescopes have been sent to space, but James Webb Space Telescope is going to make history by finding the signs of life. According to NASA, in our effort to understand the universe and our beginnings, the James Webb Space Telescope will be a huge step forward. From the first brilliant glows after the Big Bang, to the birth of galaxies, stars, and planets, to the evolution of our own solar system, JWST will investigate every aspect of cosmic history. According to the Space Administration, the science goals for the Webb can be grouped into 4 themes: first light in the universe, assembly of galaxies in the early universe, birth of stars and protoplanetary systems, and planets, including the origins of life. Let's get deeper into these objectives. The first light. Webb is frequently referred to as a time machine, and in some ways it is. We see distant objects as they were in the past because light from them traveled at a fixed pace. The Hubble Space Telescope has revealed galaxies as they were billions of years ago, but the JWST will be even more sensitive. NASA intends to view all the way back to 13.6 billion years ago, when the first galaxies were formed. Webb also offers an edge over visible band telescopes such as Hubble. According to Live Science, light from distant objects is stretched out as the universe expands, increasing its wavelength. This means that light emitted in the visible waveband reaches us in the infrared, which is the band for which the JWST is designed. One of its initial missions will be to conduct a survey of the most distant galaxies in a specific patch of sky, known as Cosmos Webb, in order to learn more about the conditions at the beginning of the universe. The galaxies over time. Galaxies are known to resemble massive groups of stars organized in elegantly symmetric spiral patterns. However, these are usually mature galaxies that were relatively close together. Hubble's tantalizing glimpses of extremely early galaxies show they are far smaller and scrappier looking than we thought. According to the California Institute of Technology, no one knows how these proto-galaxies evolved, or how they clumped together to become the larger, regular-looking galaxies we see today. With its ultra-deep picture of the early universe, Webb is hoped to be able to address issues like these. The life cycle of stars. The galaxies that make up the cosmos began to form very early on, and they've been evolving gradually ever since. The stars inside them, on the other hand, have life cycles that are more analogs to those of living things. They're born, grow, age, and die, and then the remains of ancient stars contribute to the raw material required to create new stars. Much of this process is known, but the formation of stars and the planetary disks that may develop around them remains a mystery. This is because they are originally wrapped in a cloud of dust, which regular visible light telescopes cannot penetrate, At the infrared wavelengths employed by Webb, however, all of this dust will be essentially transparent, allowing NASA to ultimately expose the ultimate mysteries of star creation. As a result, we may be able to learn more about the beginnings of our own sun and solar system. Finally, the main object and the one we all are eagerly waiting for, the search of Earth-like planets and the signs of life on exoplanets. The JWST will help in this quest in a number of ways, including studying the chemical and physical aspects of planetary systems via infrared imaging and spectroscopy. According to NASA's JWST website, its capacity to see through dust and take super high-quality photographs should offer us with a direct glimpse of planetary systems in their very early phases, such as that of the freshly created star Beta Pictoris. Webb will also examine the chemical makeup of exoplanet atmospheres, seeking for telltale signs of the elements that make life possible. This is another use for the infrared telescope, as the chemicals that make up planetary atmospheres are most active at these wavelengths. The James Webb Space Telescope is our key to the habitation of other planets. All in all, the telescope is a whole world of science in itself. From discovering the origins of our existence to black holes, aliens, and life on other planets, James Webb is going to revolutionize the space study. Before we wrap the JWST, it's worth recapping the success of its predecessor, the Hubble Space Telescope, which is now the most powerful space telescope. The renowned instrument has recorded mesmerizing photographs of the universe throughout the course of its 30-year career. Scientific discoveries based on HST data have resulted in an unparalleled amount of information on the universe's constituents, its origins, past evolution, and future evolution. HST offered solid evidence that the universe was created 13.8 billion years ago in a Big Bang, and that it has been expanding at an ever-increasing rate since then by monitoring faraway galaxies. Keeping in view the success of the predecessor, scientists have high hopes for the James Webb Space Telescope. The question is, are we going to be multiplanetary because of this telescope? Share your views about this in the comments section below. If you like the content, do give it a thumbs up, and don't forget to subscribe to the channel and click the bell icon for the updates on upcoming space videos. Until then, have a great day, and thank you for watching.